Oh my goodness, no, it's a 3-year delay, so these results are even more ridiculous, right? Yeah, so, right, so no, thank you. So for 79% of these people, what they're saying is, there's no way I'm going to wait 3 years. Thank you for pointing that out. It's even worse. I'm not willing to wait 3 years for an extra $30. Now, that might not seem strange, but if you make me wait just 3 more months for that 20, all of a sudden I become willing to wait an entire additional 3 years, right? So something in your mind is going on in the next 3 months of your life that is just wildly important, right? And maybe that's true, you know? But that's not going to wind up being a satisfying explanation for this kind of behavior because it's going to show up all over the place. And people will make decisions like this with catastrophic consequences for their lives. And by people, I mean us. Yeah?
So you're saying if I offer you $20 now or $50 in 3 years versus $20
in a month.
Or 50 in 3 years.
3 years and a month.
Or $20 in a month.
Yeah. Right. Doesn't that seem like crazy? So something about 3 months from now is just dramatically less appealing to you than now.
Does it scale matter, though? Because these are relatively small numbers for most people.
Which is another way of saying, could you please advance the slide? These are still 2.5. One of these things is 2.5 times larger than the other, but these are bigger numbers, and for college students, these are non-trivial numbers. For college professors, they're non-trivial numbers. And you see the same basic pattern. 40% were willing to wait when the 500 was now, and that went up to 88% who were willing to wait an additional 3 years if the 500 was pushed out 3 months. Okay? So it doesn't seem to be small stakes, although, of course, the real stakes in all of these are 0 because it's all hypothetical. But my guess is that if you put real money on the line, yeah, people would be more willing to exhibit kind of deleterious impatience for small stakes than for large stakes, but apparently it still holds for large stakes. And what I can tell you is that empirically, there are a lot of people who will just basically cash in 20, 30, 60 years of their lives because they're tempted now. So that's what we see. So for somewhere, so the difference here is 79 percentage points. The difference here is 41 percentage points, and here it's 48 percentage points. So for somewhere between 41% and 79%, the 3-year discount factor went from being less than 0.4 to greater than 0.4 when the early reward was pushed out a little bit. So you're thinking that there's a variation in credibility depending upon whether you think I'll give you hypothetical money now versus hypothetical money in 3 years? No. So if this was real stakes, then credibility would be an issue, and that's something that experimentalists work with a lot. I mean, I've done an experiment very similar to this, where I sent out actual checks, and I told people that they were going to come out on specific days, and I went to some pains to convince them that this is money that's backed by the university and it's going to be distributed by the university. So yeah, you have to work on that.
Can you replicate these results with people who aren't undergraduates, say people who have more stable life situations than undergraduates when they're 18?
Right, they're thinking to themselves, man, I could be in prison by the time 3 years goes by. I won't need money. Because when you get to prison, you discover you do need money. It could be. It's not actually the case. If you took older folks and did this exact experiment, I don't know what would happen. That may have been done somewhere, and you can look for that on Google Scholar. Just go to this and click Cited By and see if you find a later experiment that does this on other populations. The basic phenomenon that people want stuff now, that doesn't go away much with age, in my experience. What changes is that you become more able to overcome it. Okay? But that doesn't actually, it just doesn't solve all your problems, in my experience. One of the reasons people become behavioral economists is because the people who become behavioral economists are typically the people who have the worst problems with this stuff. Because then you don't actually need a subject pool in order to study the topic. You just look inside yourself. That's really true. Okay. So virtually no one can claim to be perfectly time consistent. And apparently there's this preference reversal, which is identical to saying that this implied delta per period discount factor isn't actually constant over time. It varies over time. So why do you think more people are willing to wait when it's 500 versus 1250? So the difference in the absolute difference is greater, the proportional difference is the same. My guess is that what's going on is that it's not that people are becoming more patient, it's just that the value of waiting is more. So that's where Matt Raven would say, oh, it's in the little U's. It's about the utility, not about the discounting. I mean, if the trade-off was $20 now versus $1 million in 3 years, you'd wait. Yeah, so it's just the amount, I think. Now, if you can explain why this goes down from 100 to 88, then I think that's a little bit trickier to explain. All right, here's some real-world evidence from that's not hypothetical stakes. That's real stakes in an interesting setting. And I'm presenting this not necessarily because I think it is the strongest empirical evidence from the real world. I'll show you other evidence in the next couple weeks that I think is also compelling. But because we're actually going to come back to this study later on. In fact, when I present some of my own work that is directly relevant to this paper, you'll see that in fact this is all a little bit nepotistic because Delavigno was my PhD advisor. So this is and Malmondier is Ulrico Malmondier, and they're married. So they went out and they got health clubs data in Boston, gyms, basically private gyms, like 24-hour fitness. And they found out two things. They had individual level data on people who had gone to these 3 different health clubs. And they found data on these things. What type of gym membership did each person buy? And I'll show you the choices. And how often did they wind up going to the gym? Okay? So the membership options were these. You could either just buy a 10-visit pass for $10 per visit. In other words, pay per visit. Just pay, essentially the equivalent of paying at the front desk. Or you could buy a membership for $70 per month to get unlimited visits. So it's a simple trade-off, and the decision between the two should depend upon exactly one thing, which is what? How often you plan to go. Well, yeah, so we get into rational expectations. It really depends on how often you believe you will go. We'd like to think that you believe you'll go as often as you plan to go. We'll look into that as we go along. Here's the reality. What they found is that the vast majority of members, of course, chose the unlimited membership, and on average, they visited the gym 4.3 times per month, which makes the cost $17 per visit. Now, we can think of this as a preference reversal in the following way. If I offer you a choice between $10 and $17, no strings attached, which will most of you choose? 17. These people are being offered a choice implicitly between $10 and $17. If I offer you a choice between you give me 10 and you give me 17, you're going to choose you give me 10. These people are implicitly being offered the same choice. Would you like to give me $10 per visit, or would you like to give me $17 per visit? And their actual behavior, which is what economists like to refer to, right? This is called revealed preference. We make claims about what your preferences must be based on your choices. So what these people are revealing is that in fact they prefer to pay $17 per visit than $10 per visit. If they had known in advance, or if they had believed in advance that they were going to go 4.5 times a month on average, then this choice would reflect a preference for walking away with less money rather than more. Right? So unless there are traces of poison on your money, this is not a good choice. Right? Does that make sense? So we can think of this as a preference reversal. Now, the preference reversal is buried a little bit because in one case you're just being asked for how much money you want to give at the door, and in the other you're being asked this more complicated question about how many times you think you're going to go to the gym in the future. Nonetheless, this willingness to pay $17 per visit by buying a $70 per month unlimited membership seems to reflect something about people's beliefs about the future. Okay? So here's one set of implications. We'll see that there are a couple of different ways to look at this, but for the time being, we'll take a look at this in a relatively simple, straightforward way. When costs and benefits are both in the future, and I'm talking about the costs and benefits of gym attendance, right? So the cost of gym attendance is that you have to get up in the morning, and then you have to pay some money. So when you push all of that out into the future, which is to say when you're making a decision of whether or not to sign off on a gym membership, members prefer attendance over non-attendance. They say to themselves, oh yeah, I'm going to make a decision right now, essentially, to go to the gym more than, where's the cutoff point? More than 10 times per month, is that right? No, what is it? 70 per month would be 7 visits per month. So you're making a decision that says, I'm going to decide to go to the gym 7 times per month because the costs and benefits of going to the gym are now all in the future, right? The gym, by the way, is counting on this. They're counting on you to do this. So they say, oh yeah, no pain, no gain, let's go for it, I'm willing to get up in the morning. And then when the costs suddenly are in the present, that is to say they wake up in the morning or they're considering waking up in the morning, suddenly they have a preference reversal and they say, all right, no gain is fine. Which is to say that suddenly they're not willing to make the same amount of investment that they thought they would. I had another example that popped in my mind, but it's gone. Now, I just want to put this on the table, and we're going to come back to this later, but just to put this on the table right now because it's applicable. A normative question, right? So we had this whole question about whether we should use willingness to pay or willingness to accept, whether we should take loss aversion seriously for normative purposes, for placing a value on things and deciding what's best. Which set of preferences should we take seriously? Was this person, should we say that was a mistake, we should have not let them buy that contract because their real preferences are, right, right? So which should we take seriously the preferences of the person you are when you wake up in the morning and don't want to go to the gym, or should we take seriously the preferences of the person who bought the gym contract earlier in time? So you can ponder that. We're going to come back to that. Okay. Well, I don't know about you, but this heat is really working on me. But together we will get through this. Okay, so we've talked about preference reversals as being an anomaly, a violation of discounted utility model. And now we're going to talk about another implication of the DU model, which will lead to another anomaly. The DU model implies that discounting will be time invariant. Now, I've already shown you some evidence that discounting is not time invariant. Now we're going to poke into that a lot more carefully. In fact, this is not an implication, it's an assumption of the discounted utility model, right? So the discounted utility model says that the discounting function d of t is equal delta to the t. So that is to say that basically you're imposing as a modeling assumption that delta is constant over time, that the per period discount factor is constant over time regardless of the delay, okay? So here's something that Dick Thaler did way back in 1981, and you have it online. Again, making the assumption that utility and money is just linear, that you get $1 util per dollar, essentially. So what you can think about is this. Suppose I give you a choice of $250 now versus some amount of money in the future. So I'm going to tell you, I'm going to say, okay, now we're talking about 3 months out, and I'm going to ask you how much money would I need to offer you in 3 months, or 6 months, or however long, in order to make you willing to wait. So what is your indifference point, right, between $250 now and a certain amount of money 3 months, 6 months, 10 years in the future? Okay, so I'm eliciting your future, the future value that makes you indifferent and willing to wait. So if you say, if you're going to give some answer x of t, and I'm going to show you a bunch of data on different values of that. If you give some value x that would make you indifferent and willing to wait t months, then your implied monthly delta under the DU model goes like this, right? That indifference tells me that 250 to you is equal to the discounted value, that's delta t, times that value that you stated, x of t, okay? Now I can just solve that for delta. What that implies is that delta to the t is equal to 250 over xt, and that in turn implies that delta is equal to 250 over x to the 1 over t, okay? So if I elicit a bunch of those x's for different delays, for different values of t, then I can back out what must be your per period delta using that simple piece of math. Okay? So for example, suppose that for t equals 1 month from now you say x of 1 is equal to $300, which is actually pretty reasonable. That says you need at least $300 to wait a month for the extra 50. Then what we get is just delta equals 250 over 200 raised to the 1 over t. Here t is 1, so that's just equal to 250 divided by 200, which is 0.83. Okay? Which is a pretty small number for delta. Thank you. Right here, yeah? Is that right? Is that where I'm? Yeah, thank you. Okay. Now, if that's your 3-month delta, if you discount the utility that you're going to get 3 months from now by 83%, what does that imply for how much I would need to give you to wait 12 months, a year, or 120 months, 10 years, okay? Under the discounted utility assumption. So x12, right, this 0.83 estimate suggests that for you, if whatever you said for x12 would mean that 250 is equal to delta to the 12 times x12, right, which, as we've shown above, implies that x12 equals 250, sorry, this is actually slightly different math than above, divided by delta to the 12, right? So before I was solving for delta, now I'm solving for x to the 12 based on the implied delta from your earlier answer. And if we plug in 0.83 for delta, what we get is, right, 250 divided by 0.83 to the 12, and it's equal to $2,339 to wait a year, all right? Maybe that's believable. Maybe you'd turn down an extra $2,000 if we were forced to wait a year. What would imply about x120? What you get is that x120 would be equal to 250 over 0.83 to the 120th, and that is approximately 1.3. Any guesses on the number of zeros? It's $1.3 quadrillion. Yeah, so I'd probably take the 250 myself. Sorry, that's supposed to be a 250 right there. But most of you are smart enough to take the 1.3 quadrillion. the point is, this is another one of those calibration exercises that we saw Matt Rabin doing with the expected utility model. If the curvature of right, if your level of risk aversion, your coefficient of relative risk aversion, is big enough to explain why you would give up these small stakes gambles, right, 500 versus 550, it would also have to predict that you would give up insanely beneficial bets of larger stakes. So this is basically doing the same thing, right? If your discount function, if your discount factor delta is small enough to explain your short-term trade-offs, it would have to predict absolutely insane long-term trade-offs. Okay, so therefore, it's just sort of strengthens the case that it can't be the case. Now, Dick Thaler went out and did this experimentally. Now, again, this is all hypothetical, but he did the same thing, and he did it for t equals 6, 12, and 120 months. So half a year, 1 year, 10 years. And here's what he got. Okay, for 1 month, the median was 300, which, as we know, implies a monthly delta of 0.83. For 1 year, it wasn't any $2,300. It was $400, which implies a much less drastic discount factor. And for 10 years, people only required $1,000 to wait, which implies a monthly discount factor of 0.99, which is starting to get into the realm of something that we can actually believe in terms of what that would do to your long-term numbers. This is going to be fun because my printer skipped an absolutely crucial page of notes. No, it didn't. So just for the sake of fun, if your monthly discount factor, does someone have a calculator handy? So if your monthly discount factor is 0.99, your annual discount factor is going to be 0.99 raised to the 12. Can anybody do that real quick? I thought I had that written down. No, you were just texting. Did anybody get it? Yeah. 0.886. And so if you wanted to raise that to the power of 60, you would tell us how much you would discount your retirement. Well, let's say 40. No, the 0.8 whatever, 0.89 to the 60. 0.00017. That's the number I remember. So if these numbers are right, then in other words, just to say that 0.99 is already a very, very low value for a monthly delta, because it would imply that you would basically, this is how sort of 0.02 of a percentage point is how much you care about your retirement. If that's true for you, we should talk. Okay. So the point is that people are willing to wait much longer for relatively small returns than the discounted utility model predicts. So therefore, it's implausible. And what we can say is that the implied monthly discount factor delta is in fact not constant. It gets bigger the further out in time you ask people to wait. Okay. So. So subjects appear to be more patient in the long run than they are in the short run. So it's not just that they want things now and not have to wait. It's that the longer you push out the time delay, the less impatient that wanting stuff now seems to make them. Right? It looks as if if I require you to wait 10, you'd think if I made you wait 10 years that you would be even more impatient. But what this shows is that your implied level of monthly impatience actually goes down when I push the delay out. That can't possibly be right. Okay, let's skip the slide. Okay, how did I manage to skip the slide? Whoops. I am going to come back to this next time. I have absolutely no idea why this slide got dropped from this lecture. Do you have this? Do you have that in your handouts? That little graph? Okay, it's in my notes. It's not in your handouts. It's not in the slides. Fine. Let's move on. All right. Now let's start moving forward, right? So the 6 steps that we're doing here, first I show you a standard model and some of its implications, then I show you a bunch of anomalies that suggest that something's wrong, then we're going to dig into the psychology of the matter and see if we can extract something from psychology that we could then put back into the mathematical model and get an improved set of predictions. So you've read this if you've read the assigned reading on the review of time preference. I'll just simplify it a bit. So prior to Samuelson, economists like Ray and Bohm-Bawerk and others, including Adam Smith, considered 2 main issues when they thought about time preference. The first was the ability to imagine the future clearly, and the second was the ability to tolerate self-denial. Now if you'll recall, Adam Smith, who started all of us going down this track, was trying to explain what in his big famous book? He was trying to explain the wealth of wealth of nations. Okay? He was trying to explain why nations in which why some nations are wealthy and others not. Which at the time, right, this was at the beginning of the era of like really hardcore European colonialism, and Europeans were really puzzling over why is it that the people who are going out and conquering so brutally are so much poorer than us, and what can we do to make that last for hundreds of years? So the things that they came up with were things like this. Right? So what you get is a big part of the explanation they thought was that wealthy countries are those countries in which people are more willing to save. That gives them more capital, and that capital over time accumulates and you become wealthier. Why do they save? They save because they have different kind of intertemporal preferences. In what ways? They are more able to tolerate self-denial, and they are more able to imagine the future clearly. Right? So the idea here was this thinking is all driven by the idea that Europeans, and in particular English, Scottish, and Dutch Europeans, who were the ones that were really getting rolling on capitalism at this time and imperialism, are more able to deny themselves tempting payoffs than say the people in Indonesia that they were just going out to subjugate, and better able to imagine the future clearly. Now, setting aside the whole history of imperialism, I don't know if those things are true or not. The point is that they were pointing to these factors, these psychological factors, that actually make a lot of sense, right? Whether or not you're able to save money probably does have a lot to do with how you think about the future, or your ability to trade off the present in favor of the future. Huge amounts of why we save or don't save